All right, so over the past couple days, you guys watched some videos. Over 11.3, we learned about chords, parts of a circle, tangents, arcs, central angles, things like that. This is a recap of arcs and central angles, 11.3. So right now in my picture, I have a circle. Let's call that circle A, which I labeled here. Let's talk about a minor arc versus a major arc. So those are two words that we talked about a couple days ago. For me to have an arc, I need two radii. So let's say I have two radii like that. Okay, let's call this one B and this one C, just because. Okay, so based on what I'm given, I want to find out, okay, well, where is my minor arc? Where is my major arc? Okay, well, minor, you think small, so that's going to be my smaller arc, okay? Major is big, that's my bigger arc, okay? So in this case, my minor arc is this one here, because that is the smaller, okay? If I change my color, let's look at this green part. This is my major arc, because look at how long it takes me to fill in the rest of that. That is a major arc. So my orange is going to be my minor because it's smaller. My major is my green because it took me a lot longer to fill that one in. It is the bigger of the two, of the orange versus the green. Okay? Now let's talk about how do we find the measure of a minor arc versus a major arc. Okay, well that all deals with a central angle. So in a circle always equals 360 degrees. Always, always, always. We know a triangle equals 180. Quadrilaterals, 360. In this case, a circle is also 360. Okay, so if I add up all these angles here, and I know I'm drawing pretty sloppy right now, if I add up all these angles in the middle, that equals 360. Okay, so a central angle is something that comes from the center and opens out. Okay, so in this case, a central angle, if I'm looking at just the orange parts of my circle, this part would be a central angle. Okay, now right now my central angle is inside my minor arc, right? I know my minor arc is this orange piece here, okay? Okay, so to find the measure of my arc, again, this is my orange arc, my minor arc. That is labeled as the measure. I'm sorry, that is labeled as BC with an arc on top. Okay, so let's talk about how to find the measure. So let's say that my central angle, let's say that was, let's go 47 degrees. So that angle right in here, 47 degrees. That means, and this only happens if the if the angle is touching that center. In this case, it is touching that center. The measure of my arc is going to be the same as that central angle. Okay, so in this case, the measure of BC arc, my minor arc, is 47 degrees. Okay, they're going to be the same. All right, I'm going to add one more point here. Let's call this one D. Let me just make these better points here. All right. My major arc, again, we talked about, was this one in the green, which I'm filling in right now. This is my major arc. So my major, let's change my color. Typically, major arcs are labeled with 3 letters. Okay, so I would go in order. So in this case, to get from B to C, I didn't go this way, right? That would be my orange, that's my minor. I actually went around this way, so go in order. First I see B, then I see D, then I see C. So the name of that green is B, D, C, again with that arc on top. That means my major arc. Okay, so for my minor arc, what I did is to find the measure of my orange highlighted, this part here, It was just the same as the measure of my central angle. Okay, well now I want to find the measure of that green highlighted part, this part here. Well, because a whole circle equals 360 and partial, the part that I know right now is 47, what I'm going to do is 360 minus 47. That gives me my major arc. So in this case, when I subtract 360 minus 47, I should get 313 as the measure of my major arc. All right, I'm going to erase all this stuff. Let's talk about a semicircle. Well, what do you think of when you hear semi? Maybe think of big, right? Semi truck. In this case, semicircle is half of my circle. So that is always with a diameter, which we know what a diameter is. Okay, that goes from one end of my circle to the other end and has to go through my center. Okay, so here I have my diameter in the blue. I'm sorry, in the green. Let's call this part B. Let's call this part C. Okay, so for a semicircle, which is half of a circle, the measure of this arc, now in a semicircle, I don't really have a major or a minor arc. The reason being is they are both the same. So this green part is 180. All I did was take 360 divided by 2, right? A semicircle is half of a circle, so the measure would be half of that 360, which means that this side is also 180. All the arcs that I have, they should all add to be 360 if I'm talking about the entire circle. So the last example that we did, we had my minor was 47 degrees and my major was 313. Well, if I add those together, I should get 360, which I do. So I know that those are correct. Okay. But again, for a semicircle is always, always, always 180. So let's make that note. Semicircle is 180 degrees. And then my full circle is 360. Okay, let's talk about arc addition postulate. So let's say I have some points on my circle. Let's call this one X, this one Y, and this one Z. Well, I want to find the measure of X, Y, Z arc. Okay, well, let's go in that order. Let's find out which arc I'm talking about. So I'm going to go in this order that it tells me. So I'm going to X first, to Y, and to Z. So I want to find the measure of that arc. Let's say, I'll break this up a bit. Let's say this part was, let's do 90 degrees. And let's say this part here was, let's do 120 degrees. Okay, so I'm going to erase actually this part for a second. So let's talk about this arc here. Well, what is the measure of that green arc? Again, if my central angle is 90, then the measure of my arc is also 90. Again, only if it comes from the center. In this case, that is from the center of the circle. Okay. All right, let's talk about my blue arc. Okay, well, the angle in here is 120, so how much does the arc equal? If you haven't guessed it, it is 120 as well. These are the same, as well as those 90s are the same. Okay, well, I want to find the measure of the blue and the green put together. How do I find that? Well, it's similar to segment addition postulate way back when, in the beginning of the year. Segment addition postulate was something that we used to add segments. Okay, if we remember, small plus small gives me big. Well, in this case, my one of my smalls is this green one. Another small is my blue one. And to get the entire big thing, add them together. So what I want is the measure of xy plus the measure of yz to give me that entire measure that I need. That one there. Okay. So let's add them. So I have 90 is my xy plus 120. Okay. Well, what is 90 plus 120? The measure of x, y, z should be 210 degrees. 210 degrees. Okay, and this is for arc addition postulate. Okay, we're going to start with another scenario as well. I'm going to erase all this stuff. We're going to talk about arc length, which is another thing that we talked about. I'm going to erase all this stuff that I have on here. Let's do a bigger eraser. Try not to get rid of my circle here. Okay. Next thing we talked about was arc length. There is a formula for arc length. Okay, this formula, if you remember, was the measure of my arc, so the measure of my arc, whatever that may be, over 360 times 2 pi r. Okay, let's practice. So let's say I have an arc here. Let's call this one S and the side T. I want to find the measure of ST. Okay, so what I want to know is how long is that? Not in degrees, because what we were doing earlier was degrees. I want to find the actual length, okay? So in order for me to find that, there's a couple things I have to know. I have to know my arc measure, and I also have to know my radius. Okay, well, let's make my radius. A radius is half of my diameter. A radius goes from the center to the side, so I do have two of them, actually. This is one radius. This is another radius. So I have two radius, which is awesome. I just don't have measures yet. So let's fill in some measures. Let's do 5 centimeters for my radius. And of course, these would be the same because all radii are equivalent, congruent. Okay. Let's say my arc here, or I'm sorry, my central angle was, let's do 110. Well, that means that my arc is 110 as well. Okay, well, I want to find the measure of ST. Not in degrees, this one's in degrees. I want to find the actual measure. So I'm going to use this formula. So I have the arc measure, which is 110 over 360, which is from my formula, times 2 pi my radius. My radius in this case is 5. Plug that into your calculator. What do you get? So you get 110 divided by 360 times 2 pi r. My r is 5. This one you will get a decimal. I should get 9.60 centimeters as my length of ST. Okay, so there's a few things that we talked about in 11.3. We talked about minor and major arcs, a semicircle, my arc addition postulate, and then now my arc length that we just went over. Okay, the biggest thing to take note is how to find your arc length, what a semicircle is, how much does a regular circle equal, and what's the difference between a major and a minor arc, and how do I find those angles? Okay.